Okay, so welcome to this video. We are going to be looking at quiz one. So quiz one has 20 questions, but very short questions. That's what we're going to be looking at in this video. Okay, so let's start from question one. So question one, they were saying define a set. So I've already written the definition there. A set, okay, is a well-defined collection of distinct objects. Okay, that's the definition, and you're free to use any definition, okay, of what a set is, as long as you do not run away from uh, the meaning of what a set is. All right, question number two, they're saying if A contains the elements 1, 2, 3, 4, and B contains the elements 3, 4, 5, 6, find A minus B. Okay, so to find A minus B, there are two ways there. You can use the one for the complement. So meaning you have to find like a universal set when you combine elements from set A and B. Okay. Or you can just use the direct method that I'm going to use here. So I'm going to say set A has 1, 2, 3, 4. Okay, and then I say minus set B has 3, 4, 5, and then 6. Okay, so this simply means that whatever element, okay, I can see in set A, okay, and it's also in set B, it's going to cancel out. So in the set A minus B, okay, only the elements that I cannot see in set A should appear. Okay, so that simply means that in set A, I can see this guy here, the 3, okay, I can also see it in set B. I can see 4, I can also see it there. So the 4 have cancelled out. I'm only remaining with what? 1 and 2. So that would be the answer there. Or if you want, you can say, let the universal set, okay, let the universal set be, you combine all these elements, so meaning from 1 to 6. So I'm going to say my universal set is 1, 2, 3, 4, and then 5, okay, and then 6. Okay, and then this A minus B is the same as A intersection B complement. So my set A is 1, okay, 2, 3, and then 4. Intersection the B complement. So now, since we have set this to be our universal set, we can easily find the B complement. So B complement will be equals to all the elements that are in set all the elements that are in this universal set, but they're not appearing in B. So that will just be what? 1 and 2. Okay, so here I'll say intersection 1 and 2. And then what is common between these two sets is still 1 and 2. Okay, so you use whatever method that you want there. All right, we move to question 3. So question 3, they're saying let set A be a set of all x's such that x is a vowel in this word here. So we know what vowels are, right? So those are A, E, O, O. So R, A, E, O, U. These are vowels. So we want to list this set now into roster form. So I'm going to say set A is equals to. So how many letters here are vowels? Okay. So I can see E is a vowel. I'll write it there. Okay. T, S, no. H, no. E is also a vowel. Okay. So I only list unique members. So I can see E again, so I can't write it again. Or I can also see it there. And then R is not a vowel, Y is not a vowel. So this is the set A. If I do what? If I list it down like that. Okay, so we move to question 4. Question 4, they're saying, if two sets have the same number of elements, but not necessarily the same elements, they are called, okay? So this one is very easy. They are called equivalent sets. Okay, equivalent sets. So e.g., I would say, let A be the set that contains 1, 2, and 3. And then let set B be the set that contains, okay, A, B, and C. We see that these two sets here have the same number of elements, but the elements that are contained in that set are not necessarily equal. So we are going to say A is equivalent to what? To B. Okay, so two sets can only be equal if they contain the same number of elements and the exact same elements. That's when they will be equal. All right, move on to question 5. Question 5, they're saying a binary operation star is commutative if, okay, A star B is equal to B star A. Okay, if this is achieved, then we say that the binary operation there is what? Commutative. Okay, number 6, they're saying simplify root of 20 plus 2 root of 45 minus root of 80. So here to simplify it, okay, I'm going to express this root of 20 as 4 multiplied by 5 plus 2. Then inside here, I'll say 9 multiplied by 5. Okay, minus the root of, and then that 80 there, okay, that 80 there is the same as 16 multiplied by 5. Okay, so now I'm going to distribute the root. So it will be root of 4 multiplied by the root of 5 plus 2 multiplied by the root of 9 multiplied by the root of 5 minus root of 16 multiplied by the root of what? 5. So root of 4, we know it's 2, then root of 5 plus here to be 2 multiplied by the root of 9 is 3. So 2 multiplied by 3, that will be 6 root of 5 minus here the root of 16 is 4, and then I have the root of 5. Okay, so I can combine this because they all have the same surnames now. Okay, this is just root of 5, root of 5, so I can combine. So 2 plus 6, I get 8 root of 5 minus 4 root of 5. So now when I subtract this, I get my answer as 4 root of what? 5. So that is the final answer there. Okay, we move. So if you have any questions, you ask. So question number 7, they're saying simplify the set B complement intersection A union B. Okay, so here I'm just going to use set laws. So I have B complement intersection A union what? B. So I'm going to do expansion here. So I'll say this B complement here multiplied by the A, okay, or expanded to the A. I get B complement intersection what? A. Okay, and then there's this intersection in the middle. Okay, there's that intersection in the middle. Oh, there was a union there. Why did I write intersection? So there's union there. So there's this union in between. So I'll write it the union, and then I say B complement with the intersection multiplied by B. I get B complement intersection B. So now this will be B complement intersection A union, okay? Here I'm intersecting a set with its complement, okay? So intersecting a set with its complement always gives an empty set, okay? Because if something is in set B, okay, then it can't be it can be in its complement as well, okay? So B complement intersection B is always an empty set. Okay, or A complement intersection A, it's always an empty set. In short, any set intersecting with its complement is going to be an empty set. Okay, but now what is the union? Okay, what is the union of this part with the empty set? Remember the union, you are grouping everything. So we're getting the empty set, we group it with the set that we already have there. So that will just be B complement intersection A. And this guy here, I can write it as A intersection B complement, which is the same as A minus what? B. So A minus B is the same as whatever we were given there. So any questions there? Okay, look at number 8. Number 8, they're saying set A is 3 to 5, where 3 and 7, I mean, where 3 and 7 are not included. B is from 4 to 9. And then the universal set is from 0 to 10. So I'm just going to, okay, so what's the question here? Can't see the question. So I'll go back to this part here and check the question. So that was question number what? Okay, so write down A union B complement. So let's get it, this part here. Okay, so want to write down A union B complement. So we can't do that unless we use a number line. So I'm going to write a number line here. Okay, so on this number line, we're told the universal set is from 0. Okay, let me just get the pencil. It's from 0 all the way to what? To 10. And the 10 and the 0 are not included. So I'll draw open circles at the end, like that. Okay, and then I have A, which is 3 to 7. So 3 can be somewhere there, 7 somewhere there. B is from 4 to 9. Okay, so let's plot them. So if I plot A, it's from 3 to 7. Okay, and the 3 and the 7 are not included. So I'll go from there all the way up to what? To the 7. And then I'll put an open circle there since the 3 is not included even there. So this is my set A. And then let's plot set B. B is from 4 all the way to 9, and the 9 and the 4 are included. So I'm going to draw a shaded circle here. Okay, even there to be a what? Shaded circle. So this here will be my B. Okay, that there will be my what? Will be my B. And then from there now, let's get A union B first of all. Okay, so A union B is everything. Starting from here, okay, up to 9 there. That's my A union B. Okay, so if I write down my A union B, it will be equals to, where it's starting here, it's at 3, but the 3 is not included there. And then it's going all the way to 9, but the 9 is what? Included. So this is my A union B, but now I want to find its complement. So its complement is going to start at the end point here. So this is at 3, right? Where the A union B is starting. So at 3 here, the 3 is not in the A union B. So meaning it is in the what? In the complement. And then I go to the left all the way to this 0, which will not be included. Cool, because it's not there in the universal set. So this is the first part, okay, of A union B complement. And then the other one will start at 9 here. So the 9 was included, so it means in the complement, it won't be included. Okay, in the complement, it won't be included like this. So this one will be the second part of the what? Of the B union, of the A union B complement. So it will be A union B complement will just be from 0 all the way to 3, and then union from 9 all the way to what? To 10. Okay, so that one there is my A union B complement. So any questions there? Okay, let's proceed. We look at question number 9. Question number 9, they're saying express 5.2 39 as a fraction of integers. So we can see that on 2, 3, and 9 there's a bar. So meaning that those 3 numbers are repeating. So if I was to rewrite that number, it would be the same as 5.239, and then they repeat again 239, 239, 239, 239, just like that until forever. Okay, so the bar there on top simply means the numbers that are below that bar are repeating. So if I want to convert a repeating decimal number, okay, to if I want to convert a repeating decimal number to a fraction, then I just have to find 2 numbers such that immediately after the decimal point, I have the repeating part. So it's going to be x is equals to, I'll get this same one here. So 5.239 because it has a bar there. So you can see immediately after this decimal point, I have this part that is repeating, right? Okay. And then now I want to find another number, okay, from this number such that immediately after the decimal place again, I have the part that is repeating. So I want to move this decimal point here 1, 2, 3 times. Okay, so if I'm moving this point 3 times, then I just have to multiply this guy by 1 with 3 zeros, which is what? 1000. So I'm going to say 1000x is equal to this decimal point now where I've moved 1, 2, 3 times. So it will be 5239 point, okay? The 3, I mean 239. Okay, you can write 239, 239, but I'm just going to write it bar on top like that. So you can see that what we require in order for us to turn this into a fraction, we found it. Okay, we found two numbers such that immediately after the decimal point, you can see the repeating part, the repeating part. So why are we doing this? So that when we subtract these two numbers, the repeating part is going to cancel out. Okay, so I'm going to say 1000x is equals to 5239.239 bar. Okay, and then I'm going to put here down the x is equals to, the x is this 5 point. So the 5 will be there. The point should be in the same line here. And then I have 239 bar. Okay, and then I'm going to say, let's subtract these things here. So I'm going to say minus here. So 1000x minus 1x. I'm just going to get 999x is equals to, and then here you can see that after the decimal point, when I subtract these two numbers, after the decimal point, because I have the same things here, it's just going to be 0, 0. So this here should always be your goal. After you subtract those two numbers, okay, the repeating part should disappear. And then now I just have 5,239. I subtract a 5. So I'm going to get 2, not 2, I'm going to get 5, 2, 3, 4. Okay, so I just want to find now this x in terms of a fraction. Remember, x was equals to what we were given there. So I'll divide both sides by 999. So x will just be equals to 5, 2, 3, 4 divided by what? 999. Okay, and then you ask yourself, is there any number that can go into here and here without leaving a remainder? Okay, there's no number, so we end there. So this here is the fractional form of this number that we wrote there. If you want, you can punch it on your calculator. You are going to see that's going to give you that same number that we had, that had the repeating 239. Okay, so any questions there? So this question is coming in the exam. Okay, it's going to be there. So you just have to know how to do it. Okay, let's move to question 10. If there's no question. So here we've been given that the modulus of A is equals to X, simply meaning that the number of elements in A is equals to X, number of elements in B is equals to 7, number of elements in A intersection B is equals to 2, and the number of elements in A union B is equals to 10. Find X. Okay, find X. So here we just use the formula for the union of two sets. So I'm going to say union of A and B is the same as, okay, A plus B and then minus A intersection B. But now here I have the moduluses. So I'll put modulus here. Even there I put modulus, modulus, modulus. Okay, so this here was given as 10 is equals to, this guy here was given as X plus this is 7 minus this guy is 2. So I want to find this X. So what do we do? Like terms together. So it will be, okay, it will be 10 is equals to X, 7 minus that, it is 5. And then 10 minus 5 is equals to X. So meaning X is just equals to what? To 5. So the value of X there is simply 5. Okay, look at number 11. Number 11, they're saying write the complement of set A in the universal set U using the rule method. Okay, so what is the rule method? Rule method is the same as set builder notation. Okay, set builder notation. So we just want to write the complement of A in the universal set U using the set builder notation. Okay, so how are we going to write it? Okay, so I'm going to say the complement of A is a set of all x's. Okay, it's a set of all x's such that x is a member of, okay, x is a member of the union set, okay, but X is not a member of A. Okay, so this description here indicates the complement set of what? Of A. So the complement of A is a set of all X's such that X is a member of the union set, but X is not a member of what? Set A. So that's why we can write it in set builder notation there. All right, so we look at question number 12, which is on rationalizing. So this one is very nice. So it's 2 minus root of 2 over 2 plus root of what? 2. So how do we rationalize such? We multiply by a special one. So it is a 1, but we are writing it in terms of expressions. So we are writing it in terms of what we call as the conjugate. So we're going to multiply the top part and the down part by the conjugate of the denominator. So the conjugate is this same thing, but with a minus sign in between there. So it will be 2 minus root of 2, and then on top it will be 2 minus root of 2 as well. So you see that here I'm dividing the same thing. So this is the same as 1. Okay, so that's why we call this part here as a special one. So now from there, we just have to multiply, okay, throughout. So on top there, we can say 2 multiplied by 2, that would be 4. 2 multiplied by minus root of 2 to be minus 2 root of 2. And then minus root of 2 multiplied by 2, I get minus 2 root of 2. Then minus root of 2 multiplied by minus root of 2, I get plus 2. Divide this all by what we get when we multiply two conjugates. You just get the first term, you square it, and then you say minus. The second term, you also square it. So what I get is that on top, it will be 4 plus 2. That will be 6. And then this here will combine. So that will be minus 4 root of 2 divided by, this here will be 4 minus what? What is root of 2 to the power 2? The square and the root cancels out. So I have 2. So that will just be 6 minus 4 root of 2 divided by 2. And then I can divide both sides by 2. So the 2 divides the 6, it is 3, minus the 2 divides the 4, it is 2 root of what? 2. So this is the final answer there. So we have rationalized the denominator. Okay, or in simple terms, we have made the square root in the denominator to disappear. That's what rationalizing the denominator is. All right, so any questions there, guys? Okay, let's move. We go to question 13. Question 13, they're saying, how many proper subset does a set with 5 elements have? Okay, how many proper subsets does a set with 5 subsets have? So here we first have to find the total number of subsets. So the total number of subsets is equals to 2 to the power n, where n is just the number of what? Elements. So I'm just going to write 5 there, is equals to, and then 3, 2. So that will be 32. So the total number of subsets there are 32. And then now, of the total number of subsets, okay, we have, is it 1 or 2? We have sets there that are improper subsets. Okay, so what are the improper subsets? Anyone who knows them? What are the improper subsets that are within a set? Hello? Guys, you do not know the improper subsets and the proper subsets. Okay, so we have two improper subsets. Okay, so we have the set itself and the empty set. The set itself and the empty set are the two improper subsets. So of any total number of subsets that you have, 2 of them are going to be improper, and then the rest are going to be proper. So I'm going to say improper here, subsets is equals to the total number of subsets always subtract the two that are improper. So these two here are the empty set and the what? The set itself. Okay, so yeah, so that would be 30. So the total number of, I was supposed to write proper here, not improper. Okay, so the total number of proper subsets are just going to be 30, or whatever the total number of subsets you have, minus the two improper subsets. So in this case, we find 30 there. All right, let's move to question 14. Question 14, they're saying complete the table for the set minus 1, 0, 1 with the operation A star B is equals to AB. So I'm going to draw like a table here. So this will be like a table. Okay, so on this table, I'm going to say here I put my operation, which is star. Okay, then here I put these elements. So minus 1, minus, I mean 0, and then 1. Here I'll put minus 1 again, 0, and then 1. Okay, so now from here, I can divide it into some sort of to my box. Okay, even there. And then even here, I do a demarcation nicely. Okay, and then there again. All right, so we are going to fill in this box using this operation here. So they're saying A star B is equals to A multiplied by B. So meaning minus 1 star minus 1 is just minus 1 multiplied by minus 1. Okay, what am I going to get there? I'm just going to get 1 because I'm multiplying minus 1 and minus 1. So I'm using this rule here. And then minus 1 star 0. So that would be minus 1 multiplied by 0. This would be 0. Then minus 1 star 1, that would be minus 1 because it's minus 1 multiplied by 1. Then I go to the 0, 0 star minus 1, that would be 0, 0 star 0, 0, 0 star 1, there is still 0. Then 1 star minus 1, I get what? Minus 1. 1 star 0, I get 0. 1 star 1, I get 1. Okay, so I've completed the table here by using this rule. Okay, so completed. Okay, what about this one? They're saying based on the table in question 14, state an identity element. Okay, so an identity element, which we call E, should satisfy this equation that I wrote here. So meaning if you get the identity element, you combine it with any element, okay? Or you get this element, you combine it with the identity element, what you should get is the element itself. Okay, so you can see here if I do 1 star minus 1, meaning if I get this guy here, star minus 1, or if I do minus 1 star 1, what do I get? Okay, 1 star minus 1 or minus 1 star 1, what do I get? I get these two values. You can see this is 1 star minus 1, I get minus 1. 1, this one was what? This is minus 1 star 1, I get this one here. Okay, so you can see that that guy satisfies the identity what? Element. Oh, should write the element itself, which is just minus 1. If I get again 1 star 0, so 1 star 0, okay? Or if I do 0 star 1, what do I get? Okay, I get 0. Or if I do 1 star 1 is equals to 1 star 1 again, I still get 1. So you can see that this guy here, no matter what I combine it with, okay, it just gives the other thing that I'm combining it with. So here I'm combining it with minus 1, it gives minus 1. Here I'm combining it with 0, 0, it gives 0. Here I've combined it with 1 and 1, it gives 1. So that is the identity element there. Okay, so I'm going to say E there is just going to be equals to 1. Okay, so any questions there? Someone is there, mic and mute. I thought you're asking a question. Okay, I'll continue then.
Lucky. I think so.
Okay, so let me continue. So here the identity element is 1, because when you combine it with anything, you get that same thing. Okay, and then question 16. Here, this one is very simple. They're saying state one of De Morgan's laws. So we can even state 2 of them here so that you choose whatever you want. So A union B complement is the same as I distribute this complement to everything inside there. So it will be the same as A complement intersection B complement. Okay, and then the other one involves the intersection inside the bracket. Distribute the complement, I get A complement, okay, union B complement. So these are the 2 De Morgan's laws. So you state whatever you want, one of these, then you're going to get that question correct. Okay, what about question number 17? 17, they're saying, let's set A be a set of all x's such that x is equals to n plus 1 divided by 2n minus 2. And then and then n is between n is between 2 and 5. Okay, so here we assume that this n is a natural number. So if it's between 2 and 5, then n can be 2, n can be 3, n can be 4, and then n can be what? 5. Okay, so I want to put this in roster form. So the elements that are going to be in A will be based on these values of n. So the first element there will just be x is equals to, when n is 2, I have 2 plus 1 over 2 multiplied by 2 and then minus 2. So this will be 3 over, this here will be 4 minus 2. So that will just be 3 over what? 2. So this is the first element in set A. Okay, and then let's find the second one. The second one will be x is equals to 3 plus 1 over 2 multiplied by 3 minus 2, which will just be 4 over 6 minus 2, which will just be 4 over 4. So this will be like a 1. Okay, this will be like a 1. And then the third one will be when x is equals to 4. So using this, when n is equals to 4, I mean. So using this formula to be 4 plus 1 over 4 multiplied by 4. What am I writing now? So that will be 2 multiplied by 4, then minus 2. So this will be 5, okay, to be 5 divided by 4 multiplied by 2, that is 8 minus 2. So that will just be 5 over 6. Okay, then the last one will be x is equals to, when n is equals to 5 plus 1 over 2, 5 minus 2. This will be 6 over 10 minus 2, which would just be 6 over 8. Okay, so it means now we can write set A in roster form like this. It's going to be, the first one is 3 over 2, and then 4 over 4, and then 5 over 6, and then 6 over 8. Okay, so you can see that the numbers on top are increasing by 1, the numbers down are increasing by 2. So this here is my what? My set A. Okay, so any questions there? Right, let's move. Question 18, they're saying state 2 sets which are subsets of every set. Okay, so this is just the empty set and the set itself. Okay. Okay, so the set itself and the empty set are subsets of any set that you can think of. Okay, so if, for example, e.g., I have my set A, okay, then the subsets that are guaranteed, okay, to be for this set will just be the empty set and the set itself, A. Right, so those are the two sets that are subsets of each and every set. We'll move on to this guy. So given you A is this, B, what are we finding here? I think I didn't get the question. Where's question number 9? Okay. So find A complement intersection B. So let's put them here. All right, so let's do that. So we're going to say, draw a line for the universal set, first of all. Okay. And then at the endpoints, we are going to put at the endpoints, we're going to put the universal set. So there's minus 20, and then there's positive 20, and these are included. So I'm going to shade like that. Even here, I'm going to shade. So that's the universal set. Okay. And then A is minus 1 to 20, B is minus 7 to 9. So minus 7 to 9 can be somewhere there. Minus 1 to 20 can be somewhere. Oh, the 20 is already there. Okay, so meaning that my set B is from minus 7 all the way to 9. Okay, and we're told this guy here is included, the minus 7, because there's a square bracket here. Here there's a curved, so meaning the 9 is not included. So this is my set B. Then my set A is from minus 1 to 20. Okay, so meaning from minus 1 here all the way to 20. So the minus 1 is not included, the 20 is included. So this would be like this. Then, oh, no, this one is not included. This one is included. So this is my set A. But there I'm finding A complement intersection B. So meaning I have to find the complement of A. So complement of A will be a set that starts at the beginning of A and then going to the left. So since the minus 1 is not in A, it will be in the complement like this. Okay, then I'll move to the left. Even this guy here will be in the complement. So A complement is this part that I've shaded in green. So now, where is the green line on top of the blue line for the set B? Okay, it's just this part here. So that part there is from minus 7 all the way to minus 1. And then now we decide which brackets are we going to put. So here, the 7 is included. Even there, because a solid line is passing at 7, it's also included. So I put a solid one, I mean a square one. Here at minus 1, okay, there's a solid line there. And then even here, there's a solid, there's a shaded here. And then here, there's a solid line that is passing through the minus 1. So even this guy here is included. Okay, so that is it, the intersection of um, A complement and B. Okay, so any questions there, guys? Okay, let us look at the last question. So this is the last question from this quiz. So the presence of an element E, okay, such that, I think this I explained, right? So if A, I combine it with a certain element E, or I combine E, okay, with a certain element A, and I'm getting that same A, then what is this E? Okay, the E there will be the identity element. Okay, so I'm just going to write it identity there. Okay, so that's all for this quiz. Okay, so that's all for this quiz. So this simply means that now we've answered everything. So I'd forgotten to make a video for this quiz, so I thought we should revise it. Okay, so meaning quiz 1 is there, quiz 2, the one that you wrote is there, test 1 is there, test 2, the videos are all there, and then the tutorial sheets, tutorial sheet 1 is there, tutorial sheet 2, tutorial sheet 3, tutorial sheet 4, and then the assignment. Okay, so everything is there. Full videos for everything. So you guys just have to work hard passing through those videos because they are the same things that are going to come in the exam. Okay, don't run away from them. Just go through the tutorial sheets, the tests, and the exam papers that we have revised. Then that will be all. Okay, so any questions there before I end the meeting? Okay, so thank you so much. I'll end here. Okay, so I forgot to mention you can find all these videos at discretelearning.com. Okay, so discretelearning.com. Or if you want, you can install our mobile app from Play Store. So just go on Play Store, search Discrete Learning Institute. The mobile app will come. And then on the mobile app, you can even download the videos, you watch them offline. Okay, but they are also there at discretelearning.com. So you can search on your Google. You're going to find the videos to everything. Even the topic lessons are there, final exam past papers are there. Okay, so make sure you go through and revise a lot for your exam.